Hi, Mr. Pepperell here, and in this clip I'm going to talk to you about transformers in action, and more specifically how to use the transformer calculation to work out the properties of a transformer. So the national grid uses these things, which are transformers. It uses step-up transformers to increase the potential difference from power stations for transmission across the country, and it uses step-down transformers to reduce the potential difference to a level that is safe for us to use, basically. And the potential difference depends on the number of turns on, firstly, the primary side of the coil. So I'm just going to put that on here. I'll just put it up here actually with this. Okay, so this is the primary side of the coil. This is the secondary side of the coil. Okay, so it depends on the number of turns on the primary side of the coil and the number of turns on the secondary coil of the transformer. Okay, and the relationship between the potential difference and the number of turns on the transformer is given in the transformer calculation, and this is it here. Okay, what the transformer calculation says, that the voltage across the primary coil divided by the voltage across the secondary coil is equal to the number of turns on the primary coil divided by the number of turns on the secondary coil. So if we are given values of three of the parts of this equation, we can use those to work out the other one. So let's have a little try and do a question. So here's our question. A transformer has 100 turns on the primary coil. So this is going to be number n primary there, number of turns on the primary coil, and 400 turns on the secondary coil, which is this part of the equation here. The potential difference across the primary coil is 2 volts, so they're giving me this voltage, and they're saying what is the potential difference across the secondary coil, which is this number here I'm trying to work out. So the first thing we need to do is, it's very hard to work something out if it's on the bottom of an equation. So what we need to do first of all is just rearrange our transformer equation to give us the bit we want on top. So the bit we wanted was the voltage across the secondary coil. So what I've just basically done is I flipped the whole equation upside down. Okay, so the whole thing has just gone upside down like that. Okay, so whereas before I had the primary voltage over the secondary voltage, I've just swapped those two roundlets, so now I've got the secondary voltage on top, primary voltage on the bottom, and the same thing has happened for the number of coils. I've just switched those two round there. Okay, so now I've switched them round and I've got the thing I want on the top. I can start to put in some values. So here we go, let's put in some values that I know for my equation there. I know that my primary voltage was 2 volts, I know that my number of turns on the secondary coil was 400, and number of turns on the primary coil was 100. So I've put those in there, so I'm working towards getting this value that I want here. So I've just rearranged my page to give myself a bit more room. I've still got the stage I was at here. Look, I've still got the secondary voltage over 2 is equal to the number of turns on the secondary coil over number of turns on the primary coil. What I want to do is get the secondary voltage on its own. So I'm going to multiply this side of the equation by 2. So by dividing the secondary voltage by 2 and then times it by 2, basically the 2 is cancelled out. Obviously I then need to times this side by 2 as well. So what that's going to give me is this arrangement. I've got the secondary voltage here, and I can now work out with these numbers I've got here. So my secondary voltage is actually going to work out to be 8 volts, and I can see that if I look at this, it just sort of double checks for me really. The number of turns I had was 100, and it was sort of multiplied by 4 to be 400. I can see that my original voltage was 2. Well, if I multiply that by 4 as well, I'm going to get 8 volts. Okay, so that's just a little check to sort of make sure that you've got the right answer there. So hopefully that's explained a little bit more about how to use the transformer calculation. Any problems at all, just tweet me at Mr. Pepperell _Pepperell on Twitter, and I'll get back to you ASAP. Cheers!